Hello. Hello, Manchester.
Hello.
So, me, myself, and UI, we're the UI guys. Who are we? So, I'm David Gill. I'm an engineer. I've been programming video games for about 25 years, maybe a bit more. And I've been specializing in the UI part for about 15 years. And I've been at CIG for 6 of those years. And with me today is someone you might recognize, Zane Bien. And he's been at CIG since, well, practically the beginning, right? Yeah. So, what do? We're the part of the UI tech team, which is a relatively new team. And we're been tasked by Chris to improve the UI technology, to improve the tools and tech that the teams use to make UI. Now, we kind of understand that the UI is a bit of a bugbear for a lot of people playing the game, so we need to sort of take a step back, make the tools better, make it easier for people to use, to develop the game for, and hopefully, long-term, help make good UI for you to use. So what are we going to talk about today? So I'm going to talk about some of the challenges that making UI for our game are, some of the new technology we've been developing, and to meet those challenges, and then we're going to talk about a design concept and how we get a design concept to something working in game with this new technology me and Zane and the team have been working on. So this is my cue to drink some water. So, what is UI? Or more specifically, what is it in our game? What does it entail in our game? So you'd be right in thinking that the UI is like the front end and the pause screen and those menus things. So, and then that includes in Arena Commander, things like your ship selection, your loadout, the Star Marine, the lobbies, things like that. But it also includes the mobi-glass and all that entails. Kiosks that you can use in the world, this comes as UI, so shopping kiosks, item kiosks, commodity kiosks, ship selector kiosks to get your vehicle out, things like that. They all count as UI. So this image also shows quite a few UIs all at once. We've got the visor, which is about here. This is showing your heart rate and the little dude there with damage to your limbs and stuff. So this is all the visor UI. We've actually got some a hint showing at the moment on this screen, and that's also counts as UI. And then where it says business district, because we're on a tram at the moment, that's also counts as UI. So we're dealing with a lot here. And of course, the vehicle MFDs, or the multifunctional displays that we see in the vehicles, that includes these panels that you see in front of you, and then the head-up display, which is on the transparent glass, that all counts as UI. And this is just some of the things. There's many other things like door locks and airlocks and plenty of things we do. So what are the challenges in making UI for Star Citizen? Well, the first one is the most obvious answer. It's the scale of this game and the ambition of this amazing game that we're working on. The just sheer number of gameplay ideas that we have, and gameplay features, and a lot of those features all have UI to describe them. So when we're thinking about gameplay features, I mentioned some of the things like the front end and the mobi-glass, but let's say we just take the mobi-glass in isolation. That's got the personal modification app, the vehicle modification app, the star map, there's still that port mod thing, and mission manager. So this is just the mobi-glass. So if you talk about kiosks, you've got commodity kiosks, item kiosks, the ship selector kiosk. So just lots and lots of different gameplay features and stuff that all require their own unique UIs and their own ways of sort of describing that feature to the game. So even things like some of the guns have a little screen on the back that is it still got the paw? That has the screen on the back that says how many bullets or how much energy it's got in it. That's UI, and that's a unique UI that we have to make for the game. Now, The next challenge is what we call diegetic UI. Now, in what you'd call a traditional video game, and some games I've worked on in the past were like racing games, you'd have what's called a HUD, which is all these sort of game elements, like on a racing game would be the lap counter and your lap time and the total number of laps you're doing, the map, maybe your status of your vehicle and other things like that, that would be drawn to the screen but overlaid over the top of the 3D game world. Now, Star Citizen is kind of a bit different. We have diegetic UI, which means the UI actually can live in the world. You can see it working in the world, like we see with this airlock here. We've got two screens and the actual panel that you use. And then the kiosks, when you're purchasing items, these are all diegetic UIs. Now, part of this diegetic UI that Chris insists on is that it's a real challenge to make, is it being in a multiplayer game, or a massively multiplayer game in this case, that when you're using these panels, he wants all the other players to see what's going on with the UI. It shouldn't be just you that's looking at it, and that presents us with quite a challenge. The reason why this is like an important thing is certainly for the multi-crew ships. So if you're the captain of a ship and you want to see all your guys doing things at their various stations, fiddling with the shields, maybe managing the weapons and stuff, you need all these UIs to be updating and working in the game world. So that's a real big challenge that we need to overcome. One of the other challenges, but it's cool at the same time, is the way this game is funded, and by you guys, thanks a lot for that, is that we always have something live and out there all the time. So when we're developing a new UI, or even stronger than that, if we're trying to develop like a new technology, we can't just break the existing system or throw away all the existing assets because well, we won't be able to fly a ship or select a ship or buy an item. So whatever we do, whatever new technology we come up with, we need that to not break anything that's already existing in the game world. So I'll get shouted at. So another part of the scale issue is just the sheer size of the universe. So you can see this image in Port Olisar here. There's 1, 2, 3, 4, 5, 6, 7, 8, I think. Ship selector consoles there. There's a few door locks in this image, but also you've got all the shopping kiosks. And that's even before you talk about the visor and the lens, and even if you get outside and you've got all the vehicle UIs. We have to manage all these different UIs as we're going around the universe. So that they tot up really quickly, and they can actually be tens, if not hundreds, at a single location. Finally, we have lots of different manufacturers in Star Citizen that make items and weapons and vehicles and things like that. And if those things have UIs, you kind of want the style of the UI to match the thing that's showing the UI, or else it would just look weird and janky, right? So also, if you've got things like shops or subway systems or other things like that, then they would also want to match the UI in their circumstance, the context that they're in. So we can see this particular manufacturer here. So there's another level to this, is the level of technology. So some things are low technology, like this guy, which is kind of in this cool retro style, but it's meant to be a low technology level that's like 2D panels and things like that. But you might have something that's in a more advanced system, and you'd expect that UI to be, I don't know, appear more advanced to sort of make it more believable. So you might have cool hologram UIs with all floating models and stuff like that. So that's kind of a challenge that we need to cover a lot of bases here with how the UI is displayed. So when we started with the UI tech team, we had to work out what are these goals? What do we need to cover here? We need to cover the scale of Star Citizen, which is pretty difficult. We need to be flexible so we can display all different styles and all different rendering mechanisms, so drawing it in different ways. And really, really important that we don't break anything on the way. We can't just say, hey, for 3.8, none of the vehicles are going to work, or you can't do any shopping. That's just not an option here. So we can't break anything on the way. That's really important. So how are we going to achieve this, or how on a technology level, do we achieve this goal? Well, the answer is separation. I drew this image. You might be able to tell. Zane's the artist. Right, so what we do is we split the code up into just two sections, and we colloquially and somewhat confusingly call these the game and the UI. And the game deals with the storage of the information, the synchronization of that information across all the clients or all the players that are connected, and all the logic that gameplay element would have. So that's where the game lives, or what the game deals with. And then we have the UI on this side, that side. And this deals with the displaying of all this information. And this will also deal with the interface and all the interactions that you can perform with the UI. So that's like its physical representation in the world, and the game deals with all the sort of logic and information part of it. And the reason why it's called game and UI actually is it's kind of a blame thing, where when we get bugs over and say, hey, we've got like the ammo count on the back of the gun, and it always says 0, but I can shoot my gun. Say, well, is that a UI problem? Is it displaying the wrong number? Or does the gun think it has 0 bullets? And we say, hey, that's a UI problem, or that's a game team problem. Someone's got to go and fix that thing as we go. So that's why we sort of colloquially use these terms, but it's kind of confusing for anyone that doesn't know it. So let's talk about the advantages of splitting up the game part of the system from the UI part of the system. Now, the first major advantage here is to do with streaming. Now, for the UI, we have to be super aggressive with the streaming. Like, if you leave a room with some UI in, we need to throw it away immediately, because it's super expensive on resources, it's super expensive on the CPU cost. So we can't just rely on OCS, if anybody knows about that. We can't just wait till you're really, really far away and then throw it all away. We have to be very aggressive. You might actually see this being overly aggressive sometimes, and you'll walk up to some, I think the delivery lockers are a bit too aggressive in their streaming. You sort of walk up to them and they pop in, and that's because we've been a bit too keen there, so we need to balance that. So it helps us because if the game holds all the information and the UI holds all the assets and the display, then actually, as we stream, if we're really aggressive with the streaming, we can throw away the UI, and then if we return to the room, and the game information is still there, then it can pop back up by using all the information used by the game. So that's really cool advantage for us. Now, it also helps us with the diegetic multiplayer problem that I mentioned earlier, because if you can reconstruct the UI really quickly from just this game data blob as you return to the room, then as long as you can synchronize or keep in sync that data blob for all the clients that are connected, all the players that are playing the game, then anyone can reconstruct that UI at any time. So I might be using the shopping kiosk, for instance, and Zane comes in from miles away, lands his ship, comes into Port Olisar, and because the data's been synchronized, he would come over and he should be able to see exactly what I'm up to at that moment in time. So that's really cool advantage that we sort of get for free. Now, the other thing is when we work with this thing being split up into two parts, we developed a common interface, a really simple interface for them to talk to each other. Now, this comes with like two advantages also. The first advantage is that we can use that interface to bring together all these amazing game ideas and all these different systems. I always make them use one common language to talk to the UI. Because we've got many different game designs, many different gameplay programmers speaking many different languages, working in different studios across the world. We need a common way that they can all talk to the UI, so that can be developed independently. And we're not really like coupled tightly, which means they would, which means you have to either have the UI guys developing a bit of the game or have some intimate knowledge of the game. Hi, Hugo. And so if you can split them up, you can independently develop the game, and you can independently develop the UI and have the right people doing the right job. Now, if we have this common interface as well, we get this other super cool benefit, which is we can develop a new UI solution without breaking anything that we already have. We don't have to throw away all the old assets, all the legacy assets, and start again. We can say, hey, they're all cool, as long as they're talking to, so as long as the game is talking to them in this single fashion, then we're free to actually make them talk. A new UI system can talk to the game in the same fashion. They'll use the same language. So if it opens us up to developing a new UI system, then what would we want to do with that to deal with the challenges, the other challenges that I mentioned earlier? Well, again, the answer here is separating these things out is to do with separation. If we can develop a UI system with distinct areas, then the right people are going to be doing the right job on their part of the UI. So we split it up into the interface. Now this is the functional part. This would say, hey, this is what we're drawing, and these are the things that you can interact with. It doesn't tell you how that's going to look, it just says the functional part of it. So that'd be a very sort of an engineering job to do that. Then after that, we can apply a style to that, and that style we would want to apply independently from the interface itself. And then the third part would be, how would that like manifest itself in the world? Like, is it going to be some 2D graphics to the screen, like a regular HUD, like we actually see on the lens? Or is it going to be something drawn to like a texture to something in the world? Or could it even manifest itself as like some 3D models and it be a hologram or something cool that we've not even thought of yet? So we keep that separate, and we don't directly couple it with the interface or any of the other part of the UI. We do it independently. So I'm going to introduce you to the two things we've been writing, which are going to solve these problems. And they're called bindings and building blocks. So bindings is, well, it's not really much to look at. I couldn't even give you a cool image of this because it doesn't. It's a system of communication. It's about standardizing the way the game talks to the UI and the UI talks to the game. But it's super duper useful, and the benefits are going to be really broad, but it's really hard to show it as like a cool image, because we have this second system which is called building blocks, and this is the bit that you guys will see. This is the thing that defines the interface, and it's the things that you interact with. And it's a system which it uses a set of what we call widgets, and these widgets can be things like text, and they can be images, and they could be vector graphics, and then they can be things that are more interactive, so like a slider or a tick box or a drop-down menu and things like that. This is a very common way for UIs to be made. Many technologies would use this mechanism of using simple, reusable objects to make up the UI that you interact with. We don't have these big custom objects that just do one job, because you end up writing a custom object and then another custom object, another custom object. What we do is write a simple object that we can reuse in a flexible way. This really improves our development times, and long-term, it improves the UI. The second part of building blocks is we have independent styling in a way that's not too dissimilar to how CSS is applied to HTML, where you would tag a part of the UI, to say, let's say we're talking about text object. A text object might be described as title, right? So maybe the Anvil style would say it's going to use this particular font, and it's going to be left justified, and it's going to be bold or something like that. And then maybe an RSI would want it to be a bit more subtle, and it would not be bold, and maybe use a lighter font and maybe a different color and things like that. So it's independent of defining the interface, but and it can be applied per different manufacturer or whatever use case we have. And at the end, we have this decoupled rendering. So we have this, the first part, the renderer that we've made is the one that we use for all the other things. So it's kind of a straightforward 2D renderer. It renders text and vector graphics and bitmap images and things like that. So pretty straightforward, but we've been doing some experiments. Well, not experiments, actually. We've actually got it working for a particular new feature where the UI is actually manifesting itself as a series of like gateways that you fly your ship through. And it's odd because it's, as far as the interface is concerned, you're drawing a list, but actually it's a list of gateways rather than a list of text that you might see in an inventory in a shop or something like that. So that's pretty cool. It's just a way of interpreting data. So this is my drinking break. So we're going to go through the steps we go through actually making a UI, which is our pipeline, which is broken down to roughly 4 distinct areas, as you can see here. And the first stage is the design stage. Oh, oh yes, this. Anyone familiar with this? So a lot of the UI we know we're not happy with, and I expect some of you guys might not be happy with too. So one of our first targets was the elevator panels. So I want to use the elevator panel as an example for this part of the talk, because it does a really good job of telling us about the key features a UI needs to demonstrate, which is it displays things to you. It could have a dynamic list like this guy has here, and also it performs some interactions. So actually what we started looking at was the new elevator panel, which is like a cool touchpad thing, right? Oh, thank you. You really hate the other one that much. You sure we don't want to go back to this? Okay, right. So yeah, it's demonstrating some great features that we have to solve with UI here, which is we're displaying some text, we're displaying a list, a dynamic list. So when the UI is constructed, it doesn't really know how many floors there is or anything like that. It's just a list. So maybe if this one, I don't know, does this one scroll if we add more things to it, Zane?
Yes, it does.
Oh, fantastic, right. So there's stuff about this I don't know about, which is cool. But yeah, this could have 2 items, it could have 20 items, but the UI needs to deal with this. So we start off, when we were looking at the elevator panel, we got a paper design. Obviously, it's not on paper, it's on the intranet, our local intranet. And this is a paper design that my friend and colleague Dan Truffin made for the interior of the elevator interior panel. Now, an elevator panel is something we're all pretty familiar with. I suspect most people have used an elevator at some point. And it seems a bit like overkill to write a paper design about it. But this is really important. It's really important to get down the exact functionality of what we're expecting to see, what you can do in there, and what are going to be displayed at any given times. Is there going to be an indicator to say whether the doors are open or not, or is it enough to just look at the door? Are we going to have a button that can open the doors? Things like that. So it's really important because each one of those decisions that are made at a design stage has a real big impact when both the gameplay designer is actually writing the system to do the elevator, but also when we come to do the UI design as well. So these become a bit of a Bible for us, and like something less familiar, Dan Truffin also did the design for the ship mining HUD that you see in the prospector. And now that's obviously less familiar. I've never actually seen a spaceship mining HUD before I'd seen the designs, so it was really cool to, he says, right, it all works like this, the gameplay works like this. And because the gameplay works like this, we need to tell people about this and this and this, give them warnings when this happens, and then tell them how much this thing is happening, and then tell them when this is full and flashlights on. So it's concise, and it's really important to get this, because small decisions that change along the way can really impact the amount of time it takes to develop. So it impacts the costs it takes to develop, but it also means we might not end up releasing it at the right time, or worse, we end up releasing something that's not quite to design. So once we've got the paper design, we do a breakdown. Now this this doesn't mean a programmer has a breakdown when they see the design, although I did do the mining HUD, and that made me cry a little, but what I mean by this is we break down exactly what you need to know. So what is this UI panel gonna display? So here we've got like a list of floors and the current floor, and then we've also got the status of the door. And also we break down what can you actually interact with. So we list out what can you do. And on a simple elevator panel is you can request stops and you can open the door. So as far as like a game engineer would be concerned, this is sort of like how they would list that out. So we've got a list of the current floor, which and when we have the data, that's 0 here. We've got the total number of floors, the travel direction, so we could be going stationary, or we could go in a positive direction or negative direction. That's programmer talk for up and down. We've got the door status, which could be open and closed, but it could also be opening and closing, so it could have a number of different states. Could be jammed, so there's a bunch of statuses that the door could be in. And then finally we have this like dynamic list, depending on the location that elevator's at. This particular example's got 3 floors in the list. So we've got the floor, each element in this list has got a name, whether the stop's been requested, and then an interaction point, a way of calling back the game to say, please can you request this stop? So that's for each floor. So even with a simple thing like an elevator panel, you can see how it sort of quickly grows into something complicated, but we try and sort of boil it down into something simple. So how do we get the game to actually see this information that the gameplay system has buried deep down in it, somewhere? We want to expose it in a way that the UI can see it. So this is how it looks to when it's registered with the binding system. Well, I've got the same data I had on the previous panel, but this is how it looks to, essentially how it looks to the game. And this is like, it looks like a series of web URLs, if anyone see those. And that's kind of not really a coincidence. These are the addresses of where this information is held. So we've got on the left there, we've got the type of variable it is, and then on the right, the value of that variable. So this is what the UI can see. Now, we're still on the game side here, right? This is what the game is exposing for the UI to use. But it doesn't know if the UI is there or not. This could be an elevator that's on the other side of the universe. Or, well, probably not, because object container stream will get rid of that. But it could be somewhere quite far away that there's no actual UI for. So it's only when you walk up to this elevator panel and the UI goes pop into place that it can reconstruct all the things it needs to know from this information that the game has described for it. So that's how we get there. So this is an actual image from in-game when we were developing the elevator panel. Now this shows the bindings. We have a little debug thing, and it can show all the bindings. And then all the sort of color coding is all the different variable types. So we've got like Boolean types, which can be true or false, or we've got integer types, which are like numbers and stuff. And then you can see on the right that this is an image of, well, it's not actually an image, this is actually the working panel, which is taking that information and displaying it. So we have these, the text is going into the text objects, and where it says, I think it says current floor somewhere, current stop name subdeck. There you go. So it says current floor on the panel, but it actually says current stop name. Now the reason why it says transit display and destinations and not floor and elevator is because we actually use the transit system, which is a more generic system for the elevators. The transit system is actually used for things like the subway system and things like that. So it's a generic system which we use it to move people around, right? So that's the same for a subway car as it is for an elevator. So we're obviously wanting to reuse these systems. We don't want to write an elevator system and then a subway system. We want to use a generic system. So with that in mind, we've got these more generic terms than floors. We've got destinations. So, you know, elevator having destinations still makes sense. That's fine. And things like, it's called gateway index. It's the same thing. This is just a more generic term that we can use. Now, this is what we call the white box stage of an implementation. Now, a white box, the term is something we've borrowed, stolen, from the level design guys, because the level design guys will block out a level in a series of white boxes or gray boxes so they can determine whether, you know, all the scales are right and whether it's going to be cool to play by judging distances and like things look good in the world for sort of like a gameplay level before the graphics guys come in and make it look like proper and cool, because that bit's like really expensive, and then some designer goes, let's move a door like 3 foot to the left, and the artists go absolutely crazy about that. So we try and get those things sorted at the white box level. And we do the same here with the UI, that we check that all these things are kind of working in the way that we want them to. We check that the buttons are going to take us to the right floor, and maybe we check that we're getting all the information from the game at the right time, and these variables are updating at the right time. So maybe the current floor, or it says current stop name, actually switches to the correct current stop name when you reach your destination. It doesn't change to that when you start moving, and things like that. We have to work out exactly when this is timed. So we do a lot of testing at this point, try and just get it all functionally working. So the next stage is about style. So this is more of an art thing, and I'm going to hand you over to our friendly neighborhood artist / designer / all-around good guy, Zane.
Right. So now that we've kind of seen the white box kind of wireframe version of our UI, I kind of want to touch on a little bit about what we've been doing in the tech to sort of facilitate all the unique branding and theming that we have throughout our UI. So in our game, as you know, we have hundreds of uniquely branded manufacturers, themes that we need to take into account. So think of things like ship manufacturers, landing zone locations, shops, right? Item shops that you go in and buy stuff. Each of those kind of have to have a uniquely themed UI, so it actually fits in the world. So in order to do this, previously what we had to do in Flash was we actually had to bake in the entire interface into a single file for each different brand we had to create. So in Flash, so all the graphics, all the functionality, we sort of had to have a file for each different UI, for each different sort of brand that we had to create. So for instance, if we're building a new location and we needed to add a themed UI to that, and that location has things like elevator panels, transaction information screens, elevator panels like we've just seen previously, then it's a lot of work because we have to copy the binary file and then create a new one and then go into each one and intricately change each individual element to match the style whatever style that environment's going to brand or that it has. So what we've done in the tech is we actually enabled the ability to have a style sheet that applies to a set of standard components. So how we're sort of changing up the sort of the way we go about actually doing the visual design. So it's kind of like the branding and the theming is we actually have a standard set of components. And what you see here on the screen is 4 different style sheets that all have kind of like the same type of components to them. So we have a standard set, like you can see buttons. It's actually quite small here, but we'll go into actually a live demo later that actually demonstrates this and actually see a changing in real time. So what we see is a standard set of components that a designer can use, can go in and set up the functionality of the UI, and they don't really need to necessarily worry about what kind of brand it is. So if they're going to set up an elevator screen, they really only need to do that once, because all you're concerned about is, okay, I need a list, I need a few buttons, some text fields, and that's going to change this way and that way. And at that point, whatever context that's going to be applied to, whether that's going to be in microtech, kind of a high-tech environment, or maybe somewhere like Levski, which is a little bit more low-tech, as long as we have a style sheet defined for those different brands, it automatically applies. And we only need to create the UI once, rather than however many landing zone locations there are, or chip manufacturers, or whatever. So on the left, you see the kind of white box version that we've seen. This is something that the designer, like anyone internally, can use to kind of, there's no fluff to it, so there's kind of no visual distractions. It's mainly focused on functionality. To the right of that is pretty much the same thing, so just kind of like a dark theme. And then we have the microtech theme that we've designed that you saw in the demo. And then a theme for Anvil Aerospace. So they're all applying their themes to things, standard components. So we have like checkboxes, text input fields. And by the way, this is like, a small fraction of what actually it would be, but it's just kind of for the purposes of this presentation, kind of kept it simple so we could actually fit it on the slide there. So just kind of break this down a little bit. So I'm just going to demonstrate like the application of one of the style sheets to the elevator panel. So you can see here is just simply the background, right? It's white, so we apply that white background to the elevator. Then we have these kind of separators and borders that we put in. So it's pointing to where it's used in the elevator UI. Then we have the buttons. So you have hover states. You have the selected state for which floor you've selected. And finally, just kind of like miscellaneous icons and greebles and things like that. So once that's applied, we can see the actual skins, that we've defined for the style sheet start applying to the UI. So that's all the same UI, but totally different themes based on the style sheet. So that allows us to sort of scale our efforts on the UI side of things, and we can start to quickly do UI and get things into your hands much faster. So once we have that in place, then really it's kind of about testing. So I'll hand you back over to Bone to talk about that. There you go.
Thanks, Zane. It's great. So, yeah. So the final stage of making a UI that we would get in-game is the testing and iteration stage. So here we have what we hope is our final in-game version with a lovely microtech style designed by Zane. So we've switched out from our white box level at this point, and now we've got something working and is correct. So we have to test this in all these different ways. So we've got to test whether the buttons are going to select the floors correctly. We've got to test whether pressing the door open button opens the door, and also make sure it doesn't open the door when the thing's moving, so people doesn't let people get out at the wrong time. We also test in potentially in different locations. We're testing all these different locations because the data would be different, so there'd be different floors. So some, as I said earlier, we might have some with 2 floors and some with like 20 floors. And in fact, in the demo I was watching earlier, there was exactly this example. There was some with 2 floors and there's some with more floors. We also, later down the line, will be testing with different localization, different languages. Now, this means we'd have to test in things like French and German. I don't know if there's any German people here today. But the German languages brings out UI designers in cold sweats because the length of the words can change quite drastically. I don't know if anyone would translate what we've got there, but you can imagine that sometimes that these words just grow in a way that maybe doesn't make the UI look quite as neat as we've got here. So sometimes we either have to retranslate, or we have to have flexible UI that can handle these long words and maybe work out if they can get split up and things like that. So, and also at this stage, we are at the iteration stage. This is where we can make changes. And we actually made changes to this particular panel. Now, I don't know if anyone can spot what we thought was wrong with it. Anyone? Nope.
It's the numbers.
The numbers, thank you, Zane. So the numbers, the indexes on the left, go 0, 1, 2, 3, which is really odd because if you get in a lift, that's not what happens. You get in a lift, you're on the ground floor, and because the way buildings are made, you go, oh, well, we've made a first floor, we've made a second floor, we've made a third floor. So that's the way, it's natural that you make a numbering system work that way, but it's natural for the designers when they were drawing this out, well, drawing like where the gateways are, that they would go 1, 2, 3, 4, because they, that's kind of how you write. So you go top down. So we actually had to add an option to flip them around like this. So now we're looking like a bit more comfortable with how this looks. Now, the second part to this was a bit of an argument between me and Zane that I don't know if any probably non-British people here would notice that we don't start the first floor with 0. Zane insisted, and because he's American, you might have guessed, that they start their numbering system on the first floor. So Zane won this argument and shifted it down. So I'm fine with that. He's a bit more buff than I am, so don't pick on him. But interestingly, sorry? It's so wrong. Okay, we'll go back. There you go, Zane, you lose.
Oh, come on.
However, I was told by the ship guys that they start their numbering from 1 also because they don't have a ground floor. Who knew, right? So I was told this today. So that's that might save us arguing about this in the office too much. But yeah, we have to put in these options, and these are the things that you sort of find out that are not necessarily natural straight away when you're making stuff. They're things that come out when, this wasn't on Dan's original design. In fact, Dan's original design didn't have floor indexes. It just said, these are places you can go. So this was something that we added, and then it causes problems. So there you go. We probably should have listened to Dan. So how did we get here? So we made a binding system that helps the game talk to the UI in a standardized way. This really helps us with development. And anything that helps us with development helps us prove these iteration times. And anyone that's used our UI probably has noticed that we're lacking a bit in iteration times. They can sometimes feel a bit clunky. So we want to speed up our process so we can make better UIs and make better game for everyone. We've used building blocks for the interface, and that also has this independent styling, and we've left ourselves in a great position to expand the renderers. We've decoupled the renderers so we can have these cool holographic displays. Zane's done some really interesting and exciting images. Really excites Chris, but strikes the fear of God into me from a technical level. So Now, as Zane alluded to, we're going to attempt to do a bit of a live demo of this. We're actually going to stream the game live. People say never work with children and animals in live TV, but we might add live demos to this. So if it's possible, could you, if it's possible, can you do that? That's brilliant, thank you. So back to you, Zane.
So I'm not actually sure how much time we have, so we'll probably do this a little faster than planned. So what I have open here is the live feed of the editor and one of our style sheets. So this applies to Anvil, and hopefully no fires. Just to kind of give you an idea of kind of how easy it is to sort of edit some of the stuff. So we have, let's say if we want to edit one of the properties of the button. So we have like this chamfered corner and left border. And we can edit that through our style sheet quite easily. So we can change one of these properties to be a different number, and we see that update in real time. And generally, we will have this editor open on a different screen, so we can see, we have a lot more real estate to work with. This is actually a bit of a internal data editor that we're using internally, but it's basically editing the raw data of the system. So what we're meant to do eventually is actually have a layer on top of the system that we built to make it much easier for the people internally to work with. So you can notice if it's a little bit of a crude interface where we have these sections that we have to open up and so forth. But later down the line, probably be some kind of markup language that you type in and update in real time. For instance, if we want to add a button, I'll just do that quickly now. I already kind of have it set up. Like if we wanted to add like a closed door button, if you want to shut people out, and that's a feature that you're adding, we can add a button there. It doesn't have an icon because we don't have an icon on that. Yeah, the troll button, which I've purposely made a little bit slightly bigger. But we add something like that in, we hook up all the bindings, and if the skin changes, say if the context changes to, like for instance, another ship, or a different environment, it's still there, it's branded differently. So it's kind of an example of adding something to the UI, but if we have different manufacturers, it's spread all throughout the whole universe. We only need to edit it once. So it makes our lives a lot easier by using style sheets and actually separating the structure from the visuals and presentation. So I think we're getting the cue for wrapping up.
Yeah, okay. Yeah. Well, if we can just switch back to the presentation, please. Maybe I just chatted a bit too much about my stuff. Cut you short there, Zane. So the future of the UI tech, we're by no means done, but thankfully you guys should start seeing the benefit of this. And the real benefit is we get better tools and putting people in the right place to do the right job. So we've got the game engineers making the game code ready for the UI. We've got the UI engineers hooking these things up, making the interface, and we've got our great and talented artists making these styles that we can apply to the UI. So we're currently in a conversion process for a lot of this stuff. There's plenty of stuff using the UI, this new UI system in-game, but we're still using some legacy assets. Some of the things using building blocks in-game are some of the backs of the weapons, obviously the elevator panel that we talked about, the transit system. That was the first thing we tried out. I think that we showed that in a CitizenCon a while back. That was like our first test case. Hey, let's do some scrolling text. That's a very low-tech version of where we were going, but it was a good test because every client was seeing the same thing at this point. So we're in the middle of converting. So a lot of the systems have been converted to use bindings. So then we can sort of choose where and when we swap out these things. And actually, we're in a situation with the vehicles. Vehicles are all using bindings now, but we're still using legacy assets, apart from one vehicle, which is the Gladius, and the Gladius head-up display is actually using building blocks. So that's really cool that we're mixing and matching these two different systems without saying, hey, either the entire Gladius is broken or, hey, all ships are broken. You know, that's just not acceptable. I wouldn't be in a job for much longer if I said that. So we're gonna do a lot more work on the resource management, so we don't have too much. We can lower the overhead, and we can have more UIs in. And we're going to develop the tools a lot more, like Zane was saying, away from what we saw on screen there to something a lot more user-friendly, a lot more, well, artist-friendly. Artists are users as well, but a lot more user-friendly for them to develop these styles quickly and for all these different manufacturers that we talked about. And the future really is we're going to do more of these renderers. So Chris is really, really keen on seeing 3D UIs and really futuristic UIs. So he's really excited by that. So he asked me about that quite a lot. So yes, this is the end. How much time have we got? About 5 minutes?
I don't know. Yeah.
5 minutes. Okay. Well, if anyone's got any questions about the new UI tech, I might not be able to help you about implementation things, but certainly hope Zane or myself can answer you about the new UI tech.
Thank you. You said testing here.
Sorry? Oh,
Here.
hello.
Hello.
Hi.
So you spoke of testing. Do
Yes.
you have some kind of automatic testing for the implementation in like different variations? Because you said you have to test in different locations and with different options, and that should be all covered through like an algorithm, right?
So specifically for UI, no. The graphics team do have we do have automated testing for Star Citizen. We have manual testing, i.e. we have a lot of QA guys also doing this stuff, because there's no way of me knowing when or you know, if a gameplay engineer knows how it's going to be used in future. So you're right, we just don't know about all these scenarios. We don't actually have automated testing per se about for the UI, but for the graphics team, they have a thing. So they run through it runs through a series of checks and checks that that the graphics have not essentially broken when they make a major change. It takes a lot of images and compares the images with previous images. So we could definitely set this same scripting thing up to go through all the locations. We'd know, because we know where all these UIs are because they're there. So we can actually set up a camera. We could run a script, run the game, move the camera, take a picture, and sort of go through and see, you know, how does this look with Microtech in German on this spaceship or whatever with this data. So I think we could definitely set that up.
Yeah, on the visual display side of things, we actually have like a level at development level in the editor, where we actually lay out a bunch of different elements configured in pretty much every way we can imagine. And we have to make sure that all that's looking right, because if we're working on the text, sometimes that breaks. So yeah.
Hi.
Hi. Are you responsible of the design you apply to the assets, or is it another team? I mean, a design-specific team, which give you instructions to follow to design the assets?
So from a gameplay perspective, no. Well, me personally, no. I work on the technology for people on the gameplay team to implement a design. So we have dedicated systems designers like Dan Truffin, who will design, did the paper design that we see in the presentation. He comes up with like these gameplay ideas and writes them all down in a very specific way. Then we have specific, they get assigned out to the gameplay engineering teams, which is why I sort of call these guys on the game team rather than the UI team. So they would implement that and also expose the bindings ready for the UI guys to immediately use. Yeah, and then there's a job of the graphic designers. So all this separation I talk about is like keeping people doing what they do best. In the past, we were a bit coupled together. Like we we would try and hire people that could do like 5 different jobs, and apart from Zane, who seems to be able to do everything, it's kind of irritating actually. I can only program. You saw my drawing, but yeah. So if we can keep them separate, we keep these guys apart. That keeps a really good workflow.
We've talked a lot about how the data interfaces with the design team. How much of that design is influenced by how we interact with the objects? Specifically, I'm thinking about ship MFDs, because without something like Game Glass or something, they're quite cumbersome right now to go and point and click and move off into.
They're massively influenced, and we're sort of acutely aware of, Zane's like on Reddit a lot, we listen to the community a lot. What we didn't have is the ability to iterate on these issues. Like, I could give you a huge list of things that I want to change, but my remit was more from Chris, like, make this easy to do so we can change it quicker and we can get lots of people to change it quicker. We used to have a dedicated UI team, and they were just absolutely swamped with stuff, and they just couldn't get through the work quick enough. And what we wanted to do is spread the workload, and make it much easier for everyone to do. So I'm hoping now it's really satisfying to see this actually coming off now, and it's all working, and we're actually seeing the results a lot better. What we haven't done right this moment is we've still got the vehicle UI to do, but we've listened a lot to the community, and we've done massive design changes on exactly how that's going to work. So, and how it's going to be displayed. It's like a lot of the time, people's frustration with UI is sometimes the UI is broken. That's fair enough. That's kind of my fault. And sometimes actually the game doesn't kind of work the way it should. It doesn't talk to the UI properly. So we're trying to solve that problem. And sometimes the design just isn't fun, like when we get there. And like if we can't change that, it's like, oh God, well, it took us 6 months to get here. You're just going to have to put up with it. That's no good, is it? Like we need to be able to think quickly on our feet and go, right, we tried it. It wasn't that much fun, but if we just move this and change that, then actually this is going to make it a lot better. So I'm hoping that we're going to improve things. Okay, we seem to be a bit pushed of time today, and I did ramble on a bit. So thanks a lot for listening, and thanks for coming. I hope you have a great day.